Welcome to Propeller Breeze, the show for student pilots, sim fans, and everyone chasing that first solo and beyond. All information in this podcast is for entertainment and general knowledge only. Always verify with certified flight instructors or regulatory authorities before attempting anything mentioned here.
Welcome back to the deep dive. So, if you're a student pilot right now, you are probably just battling information overload.
Oh, absolutely.
You're trying to juggle checklists, you're mastering pitch and power, and all the while you're wrestling with these huge safety concepts. But if we had to pick, the one single aerodynamic nightmare that haunts every early training flight, it has to be the stall.
Right. And the fear isn't just the stall itself, it's the not knowing. The uncertainty of how to really avoid it.
Exactly. So we took a deep dive into the sources, academic papers, safety briefs, you name it all, zeroing in on the single most powerful tool for stall avoidance. That's the angle of attack indicator, or AOA.
It really is a game changer.
It's a total game changer, and today we're giving you the shortcut to understanding why it matters so much more than your airspeed indicator ever could. Okay, let's unpack this.
Let's do it.
Our mission today is pretty direct. We want to give you a real foundational understanding of what some sources call the aerodynamic health of the airfoil.
Yeah, moving beyond just memorizing numbers.
Yes. Moving you past rote memorization of speed limits into a true deep understanding of why the wing is actually flying.
And that's precisely the shift that needs to happen. Early flight training focuses so heavily on these arbitrary numbers.
Like fly 70 knots on a short final.
Exactly. Maintain 85 knots in the climb. And those are helpful rules of thumb, sure, but they only give you this very superficial, speed-based picture. We need to focus on what the wing itself is actually feeling.
Okay, so that leads us right to the big paradox.
The core paradox. And it's one that every student pilot has to internalize. Speed, by itself, is not a reliable way to avoid a stall.
And that just breaks your brain a little bit when you first hear it.
It does, because an airplane can stall at any speed.
That's the mental roadblock, isn't it? As a new pilot, you're taught from day one to live and breathe by that airspeed indicator. You're told, if the needle is high, you're safe.
Right. Green arc equals good.
But then you learn that if you pitch up aggressively at 100 knots, you will stall. So if speed isn't the final word, what should we be looking at?
Well, we rely on speed because it's easy, it's measurable, it's familiar, but it's an indirect measurement of aerodynamic safety. The better, the more reliable parameter is the angle of attack.
AOA.
AOA. Conceptually, angle of attack is the true relationship between the wing's chord line.
That imaginary line from the front edge to the back edge.
Exactly, from the leading edge to the trailing edge, and the relative wind that's hitting it. It's the direct measure of how much work the wing is trying to do.
So it's not about the plane's speed through the air so much as the angle the wing presents to the air?
You've got it. And every single wing has a limit. Our sources all define this foundational concept as the critical AOA.
Okay.
This is the precise, unchangeable angle of attack where the air flowing over the top of the wing just can't hang on anymore. The flow separates, lift collapses, and the airfoil will stall. Period.
So the critical AOA is the line in the sand. It's the aerodynamic cliff edge.
That's a great way to put it. It simplifies this whole complex mess of lift and drag down to one repeatable physical constant. The core principle to grasp is this. For a given configuration, flaps down, gear fixed, that airplane always stalls at the exact same angle.
The critical AOA.
The critical AOA.
Yeah.
And that gives you an anchor point that speed just can't.
Okay, so that stable boundary, that cliff edge, it sets up the next crucial concept from the sources, which is stall margin awareness.
Right.
We know where the edge is, but now we need to know how close we are to it right now.
And that stall margin is defined as the buffer zone, right? It's the distance between the current AOA you're flying at and that hard boundary of the critical AOA. It's like your personal safety budget.
I like that analogy. If airspeed is the speed limit sign on the road telling you the maximum you can go, then the AOA indicator is telling you how close your tires are to hydroplaning.
Oh, that's perfect, yes.
It's showing you the health of the interaction between the tire and the road, regardless of the posted limit.
That's exactly it. And that margin awareness is the main job of the indicator. It makes this abstract idea of an impending stall totally tangible. You're not trying to mentally calculate, okay, what's my weight, what's my bank angle?
Right.
The indicator just gives you the answer instantly.
And without that instrument, which most trainers don't have, the AOA is completely invisible.
Utterly invisible.
You're just relying on, the feel of the controls? Or a stall warning horn that only goes off when you're already at the edge of disaster.
Precisely. And that's often when you're at your highest workload, like in the traffic pattern, and you're just hoping that the stall speed you memorized still applies.
Okay, so this brings us to what I think is, this is the real aha moment,
Absolutely.
especially for anyone flying general aviation where conditions are always changing. We've said this. Critical AOA is a stable boundary. Let's really drill down on why that makes it so much better than airspeed.
This is the crucial takeaway. Stall speed is a moving target. It is constantly changing.
It's fluid.
It's totally fluid. But the critical AOA, it's almost immune to those variables. It's a constant physical property of that wing's design.
Okay, so let's list them out. What are the big variables that do not change the critical AOA?
Let's start with the big one, weight. A student pilot's first solo is in an aircraft that is way lighter than when they go on a cross-country with 3 friends and luggage.
A massive difference in gross weight, which means a massive difference in your calculated stall speed. I might stall at, say, 45 knots when I'm solo, but maybe 55 knots fully loaded.
Exactly. So if you're flying by speed, you have to constantly be recalibrating in your head. But if you're flying the angle, the AOA indicator tells you the truth.
It doesn't care.
Doesn't care. The wing will stall at the same mark on the gauge, whether you weigh 1,600 pounds or 2,400 pounds. The physics of the wing only cares about the angle, not the mass.
That is just. It's foundational. It removes a huge layer of mental math. But let's talk about the biggest killer, maneuvering flight, turns.
The base to final turn.
This is where airspeed completely falls apart as a safety tool.
This is probably the single most important point. When you bank, you introduce load factor G-forces. And as that load factor goes up, your stall speed goes up drastically.
Right.
In a simple 45-degree bank, your stall speed has increased by almost 20%.
So let's say I'm trying to hold that magic 70 knots on final, but I'm overshooting a bit, so I tighten my turn. I bank steeper. My airspeed indicator still says 70.
But your true stall speed might now be 80 knots.
And I'm flying 10 knots below my stall speed, but the airspeed indicator gives me 0 warning.
That is the danger. The airspeed indicator lies to you by omission. It doesn't know you're pulling Gs. The AOA indicator, though, is completely honest.
Because the critical AOA doesn't change with bank angle.
It does not change. That red line on the instrument is in the exact same physical spot, even when your stall speed has shot through the roof.
So the AOA indicator automatically accounts for that increased load. It's the perfect safety net for that high workload, tight turn where students are most vulnerable.
Exactly. Okay, let's hit a couple of environmental factors. The critical AOA also does not change with temperature or density altitude.
This is huge for anyone flying out west or on a hot summer day. You know, when the air is hot and thin, the airplane feels sluggish.
Performance suffers, right?
Yeah.
You need a longer takeoff roll. Your climb rate is poor.
Yeah, but does that change the critical angle?
Not one bit. Your performance is worse because there are fewer air molecules to work with, but the physical angle where the wing gives up is exactly the same. The red mark on the AOA indicator is the same boundary in Death Valley in August as it is in Alaska in January.
But what about center of gravity, CG?
Also doesn't change it.
Okay.
A forward or aft CG will change the plane's stability and handling characteristics for sure, but the angle where the wing stalls is still the same.
The implication here is just enormous because that critical AOA is a constant boundary across weight, bank, density, altitude. It is the single most reliable metric for flight safety, period.
You learn to fly the angle, not the airspeed.
Okay, so let's move beyond just stall avoidance. Let's talk about the practical application of having this in the cockpit every day.
Right, because it's not just a safety device. It's an efficiency and performance tool.
That instant feedback lets you be proactive instead of just reactive. It's more than a warning system. It's a performance monitor.
Exactly. The sources call this a visual representation of the airplane's energy management state.
Okay, break that down.
The energy state is just the balance between 4 things: airspeed, altitude, drag, and thrust. Think of it as your total power budget. Every phase of flight is just you managing that budget.
And the AOA indicator is showing you how efficiently the wing is operating at any given moment.
That's it. So, for example, your flight manual gives you a speed for best rate of climb, VY.
Right. But that speed is only accurate for one specific weight and altitude.
And if you just chase that number on a hot, heavy day, you're probably not climbing as efficiently as you could be. But if you fly the angle for the best lift-to-drag ratio, which is usually marked on the AOA indicator, you are guaranteed to be at peak efficiency for your current conditions.
Which is a huge deal for getting over obstacles on a marginal day. Or an engine failure. A best glide scenario.
A perfect example.
Hmm.
In a glide, the AOA indicator would show you the single perfect angle to fly to get the maximum distance over the ground. No guesswork.
It takes the math out of it. And for landing, it helps you fly a stabilized approach.
Yes, if you hold the optimal AOA, you automatically maintain the correct energy state all the way down to the runway. You learn to trust the angle, not a number that could be thrown off by wind gusts.
So what does this all mean for you, the student pilot listening?
The central idea is this. Angle of attack is the key parameter. It is the key to situational awareness and stall prevention, because the critical AOA is a stable boundary that never moves.
It never changes, even when weight or bank angle are trying to trick you.
And that stability gives you instant visual feedback on the aerodynamic health of your airplane. You're not guessing your stall margin anymore. You can see it.
It's about taking complex aerodynamics and turning it into a simple, intuitive visual cue, making the invisible visible. The AOA indicator is really a shortcut to understanding your plane's energy state.
And that brings us to a final thought for you to take on your next flight. If you now have this tool, this way to instantly visualize your wing's performance, to know the absolute best angle for a glide, or a climb start thinking about what efficiency you're leaving on the table when you fly based only on the nose attitude or a generic airspeed. The perfect angle exists for every phase of flight. Are you using the principle of AOA to find it, even if you don't have the gauge?
Fly safe, fly smart, and keep diving deep into the science behind the stick. We'll see you next time.
That's it for this episode. Keep your wings level, your brain sharp, and catch you next time in the pattern. Thanks for riding with Propeller Breeze.